I'm John Hanselman, Chief Executive Officer of Vanguard Renewables. On today's video, we'll kind of go through the history of why we started Vanguard Renewables, how anaerobic digestion works, how specifically our technology that we've brought from Europe here to the States has changed the way that America is doing food waste recycling on farm, and then how we'll impact and work with food waste generators through the Farm Powered Strategic Alliance, and how that's going to actually change the way food waste moves from being a very harmful greenhouse gas to a wonderful tool for decarbonization and regenerative agriculture. So let's go on the farm and see what's happening. So anaerobic digestion as a means of processing organic matter has been in the United States almost as long as it's been in Europe, but it was done in a very, very different way here historically in the US. And in fact, anaerobic digestion, especially in the farm community, sometimes could be a dirty word. And really what had happened historically is there were very simple, very low-tech systems that ended up processing organic matter like manure, like food waste, but unfortunately those systems didn't sequester that methane. So in fact you had those greenhouse gases still being released to the atmosphere. The systems had a tendency to clog and sediment, and really farms all across the United States started to actually reject anaerobic digestion as a method for processing their organic waste. So we started the company in 2014 really by first looking at the history of what had gone wrong with anaerobic digestion in the United States. We went around and interviewed farmers, spent time with food waste generators, and what we heard over and over again is what they wanted was reliability, dependability, and a sequestration of those greenhouse gases so that they weren't actually creating a bigger problem on the farm or a bigger problem in the environment. So we went around and looked at all of the different appropriate technologies that were available in Europe, picked the technology that you see today here, which is an Austrian system that was then revised for it to be a Canadian system, and then we brought here to the United States. We've modified it so it works in the American market well. And what it allows us to do is take in food waste, large quantities of food waste, take all of the manure from the farm, combine the two of them, extract the methane, that very dangerous greenhouse gas, clean that, use it to create electricity so that we're a self-sustaining system, but then also export that renewable natural gas back into the grid. We'll walk through today each part of the different system and how it works, but the big change here is the ability to create that redundancy and that reliability. So we have now 6 systems in New England. We have another 4 under construction at this very moment, and another 10 that will be under construction before the end of the year. Over the next 3 years, we anticipate having 100 digesters operational in 20 separate markets across the United States. So the first step that we do on the farm is we accept the food waste from our food waste contributors. What we do with that is we put it into what we call the hydrolyzation station. And that is a large submerged tank that allows us to take 5 days worth of food waste, combine it, heat it, and get it ready to be fed to the microorganisms in the main digester vessel that will then consume the food waste and emit methane. The next step in the process is combining that pre-treated food waste with the manure. So once we've had that food waste at temperature for 5 days, we pump it over into the main anaerobic digester vessel behind me. Here on the Goodrich Farm, we actually have 2 separate million-gallon vessels, so we have a wonderful reliability and redundancy in having 2 separate systems that can handle the food waste and the manure. Once that liquid manure is then sent in here, the methanogens, the little microorganisms that are in the manure, go to work on the food waste. They start eating the food waste and emitting methane. That methane is then bubbles to the surface and is captured in the membrane in that black dome behind me. We then take that gas in its raw form and prepare it and compress it to send it into the natural gas pipeline for transmission to customers like Middlebury College and other folks all across Vermont. The exciting part then is once we have extracted the gas from the food waste and the manure, we're able to take that liquid, high nutrient liquid, where all of the wonderful carbon and nitrogen that's resident in the food waste, we can now take that and turn it into fertilizer. The most important step about that is phosphorus removal. So as you'll see in this footage here, we have a phosphorus removal system. It's the first of its kind in Vermont, and that allows us to actually take that phosphorus, which historically has been overused here in Vermont and in many parts of the United States as fertilizer, damaging the watershed. We actually have the ability to take that phosphorus out. Part of our overall mission is not only to get renewable natural gas, but to work with our host farm and the farm family to make their operation more sustainable, both environmentally and economically. Dairy farmers in the United States are under intense price pressure. They're under real competitive forces from alternative milks, and to sustain them is critical to reduce their cost, as well as make them a better neighbor and a better part of the community. Every farmer that we work with, and every farmer, candidly, that I've met in the United States, understands climate change in their gut. They understand that they need to be better stewards of the land, and they want to be better stewards of the land. So part of what we do is actually extract all of the solids from the manure and from the food waste and bring that back to the farm in terms and use it as a bedding material for the animals. So this material, instead of going off for land application, actually can go back in another one of our wonderful virtuous circles and be used as wonderful organic bedding material for the animals. It actually helps increases the animals' milk production and decreases their somatic cell count, something that gets rewarded by the dairy when the milk is collected and taken to them. So once we've taken all that food waste and the animal manure, combined it, removed the gas, we then remove the phosphorus, we're left with this fantastic low carbon, high nutrient fertilizer for all of the crops that are raised here on the farm. The corn, the hay, and the alfalfa, that is the feedstock and the feed material for all the animals to produce the milk, is actually higher yield per acre and a higher nutritional yield per ton for all of the corn and hay that's produced here. What's remarkable is that wonderful closed loop where we're able to take those nutrients from the food waste and return them to the soils here on the farm and all of our neighboring farms that use this fertilizer as well. That regenerative agriculture practice is something that we're exceedingly proud of and something that we see as a real benefit not only to the farm, but also to all of the food waste contributors who send us that food waste and return those nutrients to the soils here, increasing the carbon capacity of the farm significantly. So in contrast with most agricultural systems in the United States, every one of our programs is actually run by our team of professionally trained operators and mechanics that live at the site here at Goodrich and at each of our farms. This takes the burden of operation off the farmer. Our farm partners have more than enough to do with their daily operations, just trying to keep their systems running and functioning, and to ask them to then try and do this professionally and in addition to all of the other tasks that they have on the farm is something that we thought was completely unacceptable. So we are delighted to be able not only to provide the capital to build, but also the operational expertise to make sure that these systems run 24/7 without any impact on the neighbors or on the environment. The circularity of this model is something that we think is new and different and something that can change the way food waste is seen and what it does to the environment. Remarkably here, we're able to take that food waste, extract that natural gas, but then take the nutrients, put them into that fertilizer, into that tank behind me, take those nutrients that were extracted from the soils before to create the hay and the alfalfa and the corn that's fed to the cows to make the milk, and then send it back into those fields. That's something that isn't being done here in the United States up and until the Goodrich Farm, and it's something that we feel is a real game changer for American agriculture and a real game changer for the environment.